Hi, this is Mr. Max. I am doing a quick revision question on patterns or sequences. Um, this question came up, so let's just go through it. Also made some changes to the question. So I guess for this you'll probably have to take out your calculator because there's quite the accuracy that you have to focus on. Uh, Marco is making a pattern with gray and white circular mats, as you can see. Then they say that these are forming a sequence, right? So the following table, the one below, is giving you more information about these patterns. We can actually complete this table. That is what part A of the question is asking. So I've added row or pattern 6 and 7. Initially it was only up to pattern 5. All right. So I'm just doing that because it kind of help you to solve another question, which is part C. Right. Remember, you can always pause and then you can attempt to solve these questions on your own. So as for the number of gray mats, obviously, if you have to look, you will see that in order for you to go from 6 to 9, it's like adding 3 every time. So when you add 9 plus 3 gives you 12, adding 3 gives you 15. Therefore, this one here is going to be 18. If you add 3, if you continue adding 3 to 18, you get 21. And if you continue adding 3 to 21, you get 24. Okay? If you look at the total number, and I've bolded it here so you can understand, it includes everything. It's the gray and as well as the white ones as you are adding them. So there is also a simple pattern here. If you are adding 4 to 6 here, you're going to get 10. If you're adding 5, you're going to get 15. If you're adding 6, you're going to get 21. So when you are adding 7, this gives you 28. And if you are adding 8, this gives you 36. And if you are adding 9, this gives you 45. Okay, so this is the the stuff that you were supposed to put in order for you to complete pattern 5, 6 as well as pattern 7. Now I've done it initially like that because I want to highlight something in our next question. Now, then they say you're now supposed to find an expression in terms of n for the number of gray patterns. So if you obviously look at the gray patterns, you will realize that it forms a geometric sequence. We're going to use A to represent the first term, and the first term is 6. And then it has what we refer to as a common difference, and you have seen that common difference was that 3. And that's like if you are taking the second term and you subtract the first term, you are going to get the same answer when you take the third term minus the second term, for example. So if I look at this one, it's going to be like 9 take away 6. Is it equal to 12 take away 9? Of course, that D will equals to 3. So if you are aware of the formula, otherwise you can find it by trial and error, the formula of T sub n, or the nth term, is A plus, I'll put a D in front, n minus 1. So A being 6 and then our common difference being, in this particular case, 3. There's no need for me to put it in brackets. Of course, if you do carry that D behind the brackets, I'll suppose that you put it in brackets, okay? Because that D can also be a negative number, and you should realize it is not a term on its own, but you have to distribute it over there. So that's going to be 3, and then I have n take away 1. All right, so let me just clear up that. So this is going to give you nothing but 6 minus 3, okay? That minus 3 comes from if you multiply the 3 times that, and if you multiply the 3 times the n, that gives you plus 3n. Well, if you clear this up, this is nothing but 3n plus 3. You can also write it in this particular way, okay? Right, so that's the expression. 3n plus 3. Right, so the second, or part C, is asking, it says that Marco makes a pattern with 24 gray maths. Now let us just complete from my table before. Remember we said that you are adding a 3 as you are going in. This was 18, that was 21, and this was of course 24. Okay, now they are saying find the total number of maths in this gray pattern. Okay, now also the second part of the table, obviously here where I have the 45, you can see the 28, 36, and 45. So we're looking for the total number of maths. Right, so first of all, this is what you're going to do. Now we know the formula from the previous work is 3n plus 3. If you let that equal to 24, we want to find the pattern. Okay, and if this is going to be 24 take away 3, that's obviously 21, and that gives us that n will equal to 21 divided by 3, so therefore n is equal to 7. So the seventh pattern, so if you need to find the total for the seventh pattern, then you will see that from my table that I've completed, obviously there was a reason for that. The pattern or the table for the seventh pattern obviously has a total of 45. So the answer then to that question, the total number of maths in the seventh pattern, or when n equals to 7, is going to be 45. That's the total number of, all right, maths. Very important. Of course, there are other ways to find it, but this is just straightforward, and that is why I've added those extra columns over there for pattern 6 and 7 for you to realize that. Now, let's go and look at part D of the question. So what I did in part D, I've added some information, so I brought down the diagram again. It says Marco needs a total of 6 maths to make the first pattern. Now, of course, if you are counting, you'll see that it's 6. And he needs a total of 16 maths to make the first 2 patterns. That is, if you combine them. So if you add this 6 here, okay, so these are 6 here, and obviously this gives you, now remember we can get our total from the table, or we can go ahead and we can add them. Okay, so the total from the table, 6, 10, 15, 21. Okay, also triangular numbers, if you are familiar with triangular numbers. Okay, so if you are adding this, you will see that you have a total of 10 here. And if you are adding these ones here, you obviously have a total of 21. And if you're adding, now these ones will be 15, rather. Okay, so you have what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 15, and this total here is 21. So I added this in red. He needs a total of 31 maths to make the first 3 patterns. So what that means is, in fact, the 16 will be this 6 plus 10 will give you the 2. The 31 will be all these 3 patterns. If you add them up, that is 6 plus 10 plus 15. That gives you the 31 that I've indicated. And to make the first 4, all of these, if you add them all up, 6 plus 10 plus 15 plus 21 more, is going to give you 52. Right. Now they gave you a formula. It says that he needs to a total of 1 over 6n cubed plus an squared plus bn to make the first n patterns. Now, to make a total of 6 patterns, that will be the first pattern. So you can go ahead and say, okay, 1 over 6, the first pattern plus a 1 square plus b times 1, that gives you the first pattern, which is consisting of 6 maths. You can go ahead and clear these up, and this is going to give you nothing but 1 over 6 plus a plus b equals to 6. All right. Now, I don't like to leave this equation in this form, so I'm going to do a little bit of manipulation. I'm going to get rid of this 1 over 6 by multiplying each particular term by 6. All right, there are many ways that you can do this. So the 6 here cancel, that leaves you with 1. This is going to be plus 6a plus 6b, and 6 times 6 is 36. Now, I'm going to get that 1 over, so this is going to be 6a plus 6b equals to 36 take away 1, that is obviously 35. So I'm going to let this be my equation A. And there's a very specific reason why I'm doing that. Now, as far as the other equation are concerned, because you must remember whenever they ask you to find the two variables, it then implies that you are supposed to create simultaneous equations and then solve these equations simultaneously then. All right, hence I'm writing this equation in this form: a plus b equals to c, right? Or ax plus bx. I hope you still remember ax plus by equals to c, where a, b, and c are constant. So that's the only thing I am attempting to do there, because you should realize that you have to create a pattern of simultaneous equations. Now, that means if I do the second one, for example, if I say using 16, so that will be the second one. So everywhere of an n, I'm replacing that with 2 then. So it's going to be, and I'm just trying to save my space here. So it's going to be 1 over 6, but now n, if n is 2, plus a 2 squared plus b 2. Now obviously the sum of the first two gives you then nothing but 16. And if you go ahead then, so say let this equal to 16. Right, I can clear this up. So that is 8 over 6 there. If you have 2 cubed terms, 1 over 6. And 2 squared is 4, so this is 4a, and 2 times b is 2b equals to 16. Again, I'm just going to clear this equation by having that fraction that I'm going to remove that fraction there. So I'm going to multiply each term by 6. Again, you can use any other method. Right, the 6 is cancelled here. That leaves me with 8. And 4 times 6 is 24a, and 2 times 6 is 12b, and 16 times 6, that's 60 plus 36, which is 96. All right, and then I'm just going to get rid of that 8. So I'm going to have 24a plus 12b, and that is 96. Take away the 8 that is there. And if you take away 96, take away 8, of course, that is just going to create equation, and I'm going to continue here, what is 24a, then I have plus 12b, and that equals 288. Now, I can actually divide this equation here by 4 just to have it in a simpler way. So that is 6a, because 4 goes in 24 6 times, and 4 goes here, plus 3b, and obviously 4 goes here, 22. And this is my equation B. Right, so I have then created two equations. Now you can create other equations from my initial story there in part B, okay, or in part C. When I have that in red, the stuff that I have in red over here, okay, you can create other equations. So another person can say, okay, wait a minute, I can also create equations. In this case, I can say 1 over 6, and my n here is going to be 3, okay, the first 3 terms, cube it, plus a, and that is 3 squared, plus b, and that is 3, and that equals to 31. Okay, right. Or then you can clear this up if you want to. So that is 27 over 6, and 3 squared is 9, plus 9a plus 3b equals to 31. And then you can go ahead, and also rearrange that equation. Or another person could have gone and say, wait a minute, what if I now make the first 4 patterns? Right, so I'm just going to go back, and everywhere where I have an n, I'm going to replace it with my 4. And obviously, this is now going to, so perhaps I can also remove the one underneath if I was to use the first 4. So putting up 4 over here, putting up 4 over here, and putting up 4 over here, obviously this should equal to the 52 then, as you can see. Right, and then you can have 64 over 6, because 4 cubed is 64, times 1 over 6 is 64 over 6. And then plus 4 squared is 16, so that is 16a, plus 4b. Again, you have another equation that you can create, and then you can go ahead and rearrange it in such a way that is in this ax plus by equals to c format. I just need 2 anyway to solve these equations. So I'm going to use equation A and equation B. So equation A is 6A plus 6B equals to 35. So I'm just going to bring it down. All right. So I have got 6A plus 6B is equal to 35. And the other equation is 6A plus 3B. I can actually see it is equal to 22. So this is equation A and this is equation B. So I'm going to eliminate by saying subtract equation B from equation A. And if I do that, right, I'm going to eliminate my A's there, because this 6A and that 6A is going to give you naught, and 6 minus 3, it gives you 3B. And then you have 35 minus 22. So if you do that, you're going to have 13 as an answer. And therefore, B is nothing but 13 over 3. And I'm going to leave my B as 13 over 3. You can go ahead and write it as a mixed number. Now, if I have one, I can then find the other by substituting B in either equation A or equation B. Substituting B equals to 13 over 3 into A or B, it's totally up to you, right? That is going to generate 6A plus 6. Now remember, my B, I want to substitute for B. I'm going to have 13 over 3, and this should equal to uh, 35. All right, this is going to allow me to find the value of A. Now, in case, okay, use a calculator just so that you don't make mistakes. 3 goes into 6. It goes there 2 times, and 2 times 13 is 26 equals to 35. So I have what 6A equals 35, take away 26. All right. So 26 add what gives you 35? That's 9. So this is 6A equals to 9. Effectively, I'm running out of space, but then A would be 9 divided by 6, which is the same as 3 over 2. So my value of A then, A is 3 over 2, and the value of B is nothing but 13 over 3. All right, so it's quite a mouthful, but again, remember, you can use any one of those equivalent equations, and then you can still create a pair of simultaneous equations, and then you go ahead and you solve for A and B. All right, please don't forget, we are now at 4,100 on odd subscribers. Let's work hard to get our subscriptions to 5,000. And if we can do that for the month of October, that will be highly appreciated. I'm trying to reach more students and teachers over there to assist you. I'm going to be posting quite a lot of things the coming weeks as you are preparing for the upcoming national exams towards the end of the year.